security aspects are like we have to identify the corresponding whatever the MS registered in the network. We have to identify it, we have to authenticate it, and for that purpose we use different types of identifications number like IMSI. IMSI means International Mobile Subscriber Identity for authentication purpose. Also, BS uses IMSI associated with MS registration. So for that purpose, in IS 95, we have to use one code. That one code is called as Shared Secret Data, SSD, which is used at both MS and BS for the authentication of MS. So when it matches on both sides from in mobile on mobile station and on base station, then the authentication process completed. Now, what is this shared secret data? The shared secret data is actually the 128-bit quantity and which is stored in the memory of MS, and it is readily available to BS always when it is required. SSD is never passed on air interface. Air interface is nothing but there's actually the interface between your mobile station and the base station. So SSD is divided into two sections of 64-bit each. First is SSD-A and second one is SSD-B. SSD-A is for authentication and SSD-B is for encryption purpose. SSD-A is used to support authentication procedure, and SSD-B it is used to support voice primers, privacy and signaling message encryption. So both are used for authentication and encryption purpose. So it has one random bit too. Random bit, RAND, random. Random is nothing but it is a 32-bit value stored in MS. In CDMA, the random value is equals to value received in the last access parameter message on paging channel. Whatever the paging channel responds or send the message is consisting, it is actually the random message. It is used with SSD-A for the authentication and other parameter to authenticate MS origination, termination, and registrations. So A key is the 64-bit long and it is assigned to MS. It is stored in MS permanent security identification memory. It is known only to MS and it is associated with HLR and AOC. As you know, the home location register contain different types of database, which when in foreign network is connected, it will be verified by HLR. Also, whatever the visitors coming or the calling process takes place from different MS are first of all authenticated by HLR with the help of IMSI and PMSI number, and authentication process is takes place with the help of authentication center contained in the corresponding network. So this A key is actually the 64-bit long and also known as it is only known to MS and it is associated with HLR and AUC. Now, how this SSD updated? Now, SSD updation procedure, you can observe here the diagram clearly. First of all, the MSC. So let assume that this portion is of MSC and this portion is of base station. So MSC sends an SSD update request message to base station. Base station. Random SSD is the message sent by MSD to indicate the MS needs updation. Base station sends an SSD update order message. SSD update order message to MS. It is carried using paging channel or forward traffic channel. The random SSD field of message contains the same value used for HLR or authentication computation of SSD. So SSD generation procedure takes place with the help of A key, which is associated with HLR and AOC. So A key generation A key and the random SSD generation procedure is initiated by base station. So this SSD is classified into two parts, SSD-A and SSD-B, where SSD-A is the part of authentication and SSD-B is the part of encryption, whatever the voice or the traffic is encrypted. Next part, once MS receives this random SSD, it used for SSD generation procedure. So SST generation procedure is initiated. After that, the once the MS sets SST A new and SST B new after receiving when MSC sends the updation message when it is generated SST B generate new code generated which are initialized by the MS. So MS sets SST A new and SST B new to output of SST generation procedure. So random BS is the 32-bit data number. The MS sends random BS to BS on access channel or reverse traffic channel. So this MS sends whatever the random BS number on access channel. Now previously in previous lecture I told you that access channel is used for the authentication purpose, call connection purpose or registration purpose. So that process is actually carried out with the help of access channel. So here also we need to authentication process. Actually we have studied about the security aspects, and security aspects in that we have to concentrate on, major concentration is on authentication. So MS sets a new and SSTP new to the output of SST generation procedure. So random BS is 32-bit random number. MS sends random BS to BS on access channel or reverse traffic channel. BS forward this message to MSC. This message is known as base station channel message. Here you can observe the base station channel message, order message, and it is used to verify new SST calculated at MS. Now, whatever the MSC, we have to match both SST. When this match, then authentication process will be completed. So for that purpose, BS sends challenge message. So this challenge message is received by MS. After that, once this message is received by MSC, it uses new SST as input to algorithm to generate the authentication response signature. So authentication response signature is generated. This authentication response signature is then sent to BS for comparison purpose, and at the same time BS also generates one authentication signature. Both these signatures will be compared at the base station, and if they are matched, then the authentication process is completed. So then after that, the base station will send SST update order confirmation message to MS. Okay, so this is the actually authentication process. If the received value of authentication BS and internal generator value matches, the MS executes SST update procedure, and this sets SST N, SST B to SST A new and SST B new respectively. Once this procedure is completed, the MS sends SST update confirmation order message to BS. Okay, so this is the actually means on both side the generation of SST takes place and updation of SST takes place, and uh, both will be updated for on both side, and both will be compared on both side, and both will send the authentication signature and authentication order message for the complete authentication process, and which are the security aspects in the IS-95 which are very good compared to other network. So high security is provided in IS-95 or the CDMA. So this was the part of security aspects in CDMA. Now, this second portion is related to SSTB. SSTB was about the voice privacy. Now, voice privacy is nothing but the appropriate key supplied by MSC, and it is very important. It cannot be broadcasted, means it is very private. It is only known to corresponding registered network only. It is not known to all, or it is not available publicly. So privacy is attempted with the help of encryption. So for that purpose we use SSTB code for the encryption purpose. Okay, so this is the security aspects containing in the IS-95. Thank you.